So we just began by discussing filter feeding is not the first time that we've seen that concept. This is actually the second time you all had correctly answered. The first time would be that within the sponges. Excuse me. Okay, so name a phylum we have discussed.
Like out of like
Any of them.
peripheral.
Okay. So then your lab partner, name a class out of the phylum Peripera. Nope, it's not Anthozoa. Though that is an Idarian, that's right. A class of sponges. Name a class of sponges. Name a class of sponges. Okay, name a class of sponges. That's one, asconoids. Okay, name one of the other two phylums. I'm not catching what you're saying.
I don't know how to say it. It's like starts with C and CN.
Yeah, Cnidaria. That's certainly a phylum. Name a class out of the phylum Cnidaria. Oh, your voice has changed. I'm pointing at him, but you answer the question. No, 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 no. And then finally, the hardest question I can maybe think of. How about, what was the first class that we talked about in our current phylum? That's the current phylum, but not the class. It does start with a G. And it is over there on the board too. Yeah, gastropods. Okay? So now in general, who are the gastropods?
Mollusks.
True. Those are snails, slugs. Yes, those are certainly gastropods. So what is unique that the gastropods do that we talked about in class? What process do they go through that is rather unique? Well, it has something to do with their digestion. It enhances their digestion. Let's put it that way. Well, and that would be with all of the mollusks are now digesting things extracellularly, at least the majority of them. And what we had said, it's one of those things to where it turns like this.
Oh yeah, it rotates.
Yeah, it rotates 180 degrees. But what do we call that? Also starts with a T. I think it's actually a type of exercise that you can do, whether you call them windmills, where you're touching your feet, or you're just twisting your torso like this. That's your clue, twisting your torso. Torsion, that's right. So when we went through asking these questions, and you may have said, I don't know, or I forgot, I don't know, I forgot. Okay, it's important that you try to follow along and why we want to review with them as we constantly move on. In other words, what were some of the characteristics of the peripherans? There were 3 or 4 of them. 4. They're sessile. They're filter feeders. They have pores in them. Then at the top, they have an osculum. Okay? So, as we're going through those and you think, oh my, I forgot, there, you might have to do a little bit of work or write it down or whatever it is that you have to do to enhance that. Then we moved on to the cnidarians. What do they have in common? They've got tentacles. And what's true about those tentacles? Yeah, they actually have venom inside of them. And then one more characteristic. Yes? Yes. Well, that's what actually produces the venom, though. You're not wrong, but that's not what we're getting at. Because we've already named that. Nope, that's sponges. In other words, they all look the same from the top down. Yeah, they got radial symmetry. Okay. So that's why we want to go through those. And if we're having problems with that, again, you know, maybe we forgot now. That's why we continually review those. That is some funny looking zoology there. Oh, so maybe in that class, maybe you work on your zoology. Oh, I don't know. Okay. So I think we're a little past this. Is that correct? So which one of these is on top, the X current or the in current? The X, was that a guess? You're right. The X current openings are up on top, okay? Because the in current openings here, what did we say is coming inside of that in current opening? Debris and water. And that debris could be anything from sand, silt, algae, anything that they're possibly feeding upon. Then it's just the water that would go through the X current opening, which is up on top then. So that's how we refer to them as filter feeders. This thing is not cooperating. Is this correct then? Yeah. Okay. There we go. Okay. Now, do us as humans, do we have this process as well? Now, not into our feet. That's not what we're getting at, okay? Any type of muscle, because that's what this tissue would be, is a muscle. Do us as humans and mammals, do we pump blood into our muscles?
Yes.
Of course, because they have to have oxygen, they have to have nutrients, okay? So, can this oxygen get cut off or stop from flowing? The answer to that is yes, okay? And you might think, well, how is something like that possible? Well, how many of you maybe have lounging around at home, you put your feet up and your knees lock? Okay? What possibly happens when you lock your knees when you put your feet up? I'm sorry, I didn't hear that. You're exactly right. But what do we mean by fall asleep? That would be the common answer and the correct one. But what do we mean, though? Yes, you're losing circulation. So when that happens, okay, once you release that pressure on your knees, then that blood is going to start flowing again. Although your hands, your feet, they feel kind of tingly, and you don't have any feeling in there because you've cut the blood supply off there. Okay? And yes, that happens. And one of the things that if you were to stand at attention, like maybe you're going through basic training, and in a ceremony, you have it. Excuse me, because I had to do this too. You have to stand at attention for probably 30 minutes. Don't lock your knees. In other words, there's nothing wrong with kind of moving around a little bit, because if you stand there at attention and you lock those knees, what might happen? Why are you right when you say fall? That's correct. Because what do we say about putting your feet up at home? Yeah, it's going to cut the circulation off. It's going to slow it down, and now you're not going to get brain up to your head. It says, oh boy, I'm not getting enough oxygen, and down you go.
Yeah, I was in kindergarten where we were having like a band or choir class, and you're standing up straight, and you have your knees locked, and then you faint.
Oh, geez. And he fell forward, not backwards, right?
Yeah.
Probably. Okay, so one of the things to keep in mind as this is pumping blood as well, what type of circulation are we talking about? Open or closed? Open or closed? It's actually open, because these animals, they've got blood sinuses, not capillaries. So once this blood then is supplying this to the muscular foot, the oxygen, the nutrients, and if there's no capillaries in there to continue that circulation, like in a closed loop, how does that blood get from an open area back into circulation then? What does it say here? Oh, okay, sorry, it doesn't say that. When that muscle contracts again, that is pushing that blood forward then. So it goes from the blood sinus back into circulation. Because again, there's no capillaries here. So that's why it's an open circulatory system. Okay, so I want to get through, I want to talk about this feeding. Let's just go ahead and get through half of this, and we'll save the other half for tomorrow, because we'll continue talking about bivalves tomorrow. And then what do we have on Friday? Vocabulary, and you have those terms, okay? So we'll elaborate on this tomorrow. But how is this similar, this point right here, how is this similar to something that we have learned in the past? And that's how we actually started today. Because we said that what type of feeders are these? They're filter feeders. So then we said we have seen this before. It's not the first time. This is actually the second. You're a little too far ahead when you say osculum. You have the right idea. You could say the osculum would be similar to the excurrent openings in these. Okay, so water and organic materials will enter through the ostia, dermal ostia, into the ostia then, into the spongial seal, where you have these choanocytes that are waiting, okay? And then the choanocytes have collar on them, and then what's attached to the collar? Flagella. These flagella. So then what happens to these algae? It gets trapped on that flagella, okay? Excuse me. The key point to this is trapped. So what do we see? It's not anything like that in mollusks, But what instead is trapping this material? Yeah, this mucus will trap the organic material, and then it will take these suspended materials across the gills, and where is this material taken in then? It's on the anterior side. And what is inside that mouth? It's a radula. Is that just unique to bivalves, a radula? Why not? You're correct. All mollusks have a radula, whether it's a squid, a clam, a snail, all of them have it. Okay, so that's all I have. We will catch up to you next time.